Brett, thank you. Researchers at the University of Oregon are working on a greener way to make iron for steel production. Now, iron is traditionally made using a coal-powered blast furnace, and that practice accounts for roughly 11% of global carbon emissions. Instead, researchers are using electrochemistry to turn salt water and iron oxide into pure iron with no fossil fuels required. Now, the science is complicated, but take a cup of coffee, for example. If you pour sugar in, it dissolves. Put a spoonful of sand in, and it would sit at the top before eventually sinking to the bottom.
And so that's kind of like what we're doing. We're using it's much smaller than sand, but we are using particles that don't dissolve.
Now, to put it simply, researchers insert their materials into a reactor, and the iron is refined through a series of electrochemical reactions. Now, with chemical manufacturing comes byproducts, and those may be harmful or difficult to dispose of. That isn't the case here. In fact, all of the byproducts can be repurposed.
There's a lot of things today that we need to make with cleaner resources. And so it's just fundamentally interesting to us to find reactions that we can drive using clean electric power.
Now, this system is far from being viable on a large-scale manufacturing stage. The more researchers scaled up the experiment, the more the particles settled in irregular ways, and that isn't great for making iron and steel. Still, this showed researchers that it's possible, and through a partnership with OSU and a $700,000 federal grant, researchers hope to crack the problem and determine how it can fit in the future of our infrastructure and manufacturing.